Hello friends, Mr. Burrell here. Welcome back. In the last video we talked about circumference and arc length, so the distances around the outside of a circle. This lesson we're going to be talking about area and sector area. So again, you've probably been exposed to the formula or the methods of finding the area of a circle before. So we're going to talk about finding the areas of a circle, what the area is, and finding the sector areas of a circle and what that means. So by the end of this video, by the end of this lesson, this is what I hope you're able to do. I hope you're able to find the area of a circle given the radius or diameter. I hope that you're able to find, we're going to talk about finding the circumference of a circle given the area or the area given the circumference. We're going to talk about the comparison between those two. We're going to find the sector area given an angle measure and the radius. We'll talk about what that means. And then we'll talk about a couple real-world problems involving sector area that I want you to be able to solve. So, to start, the area of a circle is measured by is a measure of the space inside the circle. So last time we talked about how the circumference is the distance around the circle. The area is a measure of this space on the inside of the circle. All this space. That's what we're measuring when we talk about the area of the circle. So the area of the circle is given by this formula. And again, hopefully this isn't terribly new information. Hopefully you've been exposed to this a little bit in the past. But the area of a circle is equal to pi r squared. Pi times the radius squared. Again, where the radius is the distance from the center of the circle to a point on the outside of the circle. That's the radius. And then note again, like we noticed in the last video, that the diameter is 2 radiuses, or double the radius, or in other words, the radius is half the length of the diameter. So this is how we find the area of a circle, pi r squared. So let's delve into this. Let's practice finding the area of a circle. So this says, find the area of each circle with the given radius or diameter. Round to the nearest tenth. Use 3.14 for pi again. So we're doing very similar to what we did in the last video, except now instead of circumference, we're finding area. So remember that the formula for the area is area equals pi times r squared. So here on number 1, again, these are in your guided notes if you decided to print them off. So area is equal to pi r squared. So the radius here is 3, so area is equal to 3.14 times 3 squared. Times 3 squared. So 3 squared, I better take care of that exponent first. 3 squared is 9. So the area is 3.14 times 9. 3.14 times 9 is 28.26 millimeters squared. When we're talking about area, we're talking about squared units. So whenever we write the units of an area, we write the units squared. So 28.26 millimeters squared. Or in other words, that's how many square millimeters I could fit over the top of that circle. Okay, here it says the diameter is 15 yards. Well, I don't want the diameter, I want the radius. So I know the radius is going to be half of that, which is 7.5 yards. So, let's calculate the area. Area equals pi, or 3.14, times r squared, or 7.5 squared. 7.5 squared, I better take care of that exponent first. I have 3.14 times 56.25. 3.14 times 56.25 is 176.6, if I'm rounding to the nearest tenth, 176.6 yards squared, or square yards. 176.6 square yards. That's the area of that circle. Number 3 says a CD has a diameter of 4.5 inches. So here's my CD right here. Do people still use CDs? I don't know. But here's my CD. Kind of looks like a donut. If the diameter is 4.5 inches, that means the radius is going to be half of that, which is 2.25 inches. So the area of the face of this CD is going to be pi r squared, or 2.25 squared. Well, 2.25 squared is 5.0625. And 3.14 times 5.0625 is 15.9-ish, give or take, depending on how you round it. 15.9 inches squared. So it'll take 15.9 squares that are 1 inch by 1 inch to cover the top of that CD. About 15.9 inch squares to cover that CD. Okay. Now, if I am given the area of a circle, I can find the circumference and vice versa. So this is something we didn't do in the last video, but we're going to talk about that if I'm given the area, I can find the circumference, and if I'm given the circumference, I can find the area. So here it says, find the radius with the given circumferences and areas, then find the circumference slash area, the other one that's not given to you. Round to 2 decimal places. Okay, so in the last video, we did talking about finding the radius. So let's remind ourselves what the formula for the circumference is. Circumference is equal to 2 pi r, which means the radius is going to be the circumference divided by 2 pi. The circumference divided by 2 pi. Well, that means the radius is equal to 43, because that's the circumference, divided by 2 times 3.14. Well, I better do this bottom of the fraction here. So 2 times 3.14 is 6.28. 43 divided by 6.28 is 6.85. That's my radius. Okay, well, so what? Why did I want to find the radius? Well, because now that I have the radius, I can find the area. Because area is equal to pi r squared. So I just found my radius. So area is equal to 3.14 times the radius squared, or 6.85 squared, which is 3.14 times 6.85 squared, or 6.85 times 6.85 is 46.92. And 3.14 times 46.92 is 147.33 feet squared. So a circle that has a circumference of 43 feet, all the way around the circle of 43 feet, is going to have an area of 147.33 feet squared. Okay, I'll go ahead and leave this one for you to do on your own. Number 9, let's do together. If I'm given the area, area is equal to 92.75 centimeters squared. That should be squared. So I need to find the radius before I am able to find the corresponding circumference for this circle. So area is equal to pi r squared. So let's go ahead and plug in what we know. Area was 92.75, which is equal to pi, 3.14, times r squared. Well, to get r by itself, I better divide by 3.14 on both sides. And I'll get r squared equals 92.75 divided by 3.14 is 29.54. Well, if I have r squared equals 29.54, I better square root both sides. We did this earlier in this trimester when we were talking about solving by the square root method. Well, the square root of 29.54 is either 5.43 or negative 5.43, but it doesn't make sense to have a negative radius. So my radius of my circle is 5.43 centimeters. Well, now in order to find the circumference is 2 pi r, or 2 times 3.14 times the radius of 5.43. 2 times 3.14 times 5.43 is 34.10 centimeters. So the circumference of this circle that had an area of 92.75 centimeters squared is 34.1 centimeters. So again, when I'm given the area of a circle, I can find the circumference and vice versa by first solving for the radius and then plugging the radius into the corresponding formula of the measurement you're trying to find. Okay, so again, area hopefully wasn't terribly new information. Now we're going to switch over and talk about sector area. So let's talk about what a sector is. A sector is the region within a circle bounded by two radii and an intercepted arc. Okay, so we talked about how an arc is the section on the outside of the circle that is connecting two radiuses. So this right here is the arc. Here are my two radiuses. So the sector area is this area of this little wedge here that is bounded by those two radiuses and the arc. So this area right here, just a little chunk of the area of the circle, is what the sector area is. That's how we're defining sector area. So here's the formula to find, here's a little asterisk here. This is a fraction of the area of a circle. An arc length was a fraction of the circumference of a circle. Sector area is just a fraction of the area of the circle. So notice here, the area of a sector is n divided by 360 degrees times pi r squared. Notice how for arc length, the formula for the arc length was n divided by 360 times by 2 pi r. So just the fraction of the circle multiplied by the circumference. The sector area is the fraction of the circle multiplied by the area of the circle. So again, notice here that to find the sector area, you just multiply the area of the circle by the fraction of the circle that that sector takes up. And the fraction of the circle that that sector takes up is found by taking the angle between those two radiuses divided by the total angles within the circle, which is 360 degrees. So again, the sector area is just a fraction of the total area. So let's practice finding that. So I'm skipping over to questions 7 and 8. It says find the shaded sector area in the following circles. So I have this angle of 100 degrees and a radius of 7 centimeters. So I'm looking for the sector area. So the sector area is equal to n divided by 360 times by the area of the circle, or times by pi r squared. Well, my angle here that's separating these two radiuses is 100. So 100 divided by 360. That's going to be the fraction of the circle that the sector takes up, multiplied by pi times r squared, or times 7 squared. Well, 100 divided by 360, I better take care of that first, is 0.278 times by 3.14 times by 7 squared, or times by 49. So 0.278 times 3.14 times 49 is 42.77. So the area of this little sector right here is 0.278, or 27.8% of the whole area of the circle, which is about 42.77 centimeters squared. That's the area of this sector right here. Okay, let's move on to this one. Right here I have an angle of 135 degrees and a radius of 14 meters. So the sector area is n divided by 360 multiplied by pi r squared. So the fraction of the circle that the sector takes up multiplied by the area of the circle, which is 135 divided by 360 multiplied by 3.14, so I write 3.14 for pi, times r squared, or 14 squared. Well, 135 divided by 360 is 0.375, 0.375 times 3.14 times 14 squared, which is 196. So 0.375 times 3.14 times 196 is 230.79 meters squared. So again, the fraction of the area of this circle that this sector takes up is 0.375, so 135 divided by 360, multiplied by the area of the circle gave me 230.79 meters squared. That's the area of this sector right here. Okay, here's some real-world type style problems you might see in association with sector area. This is number 6 and number 9 on your guided notes. So 6 says, the beam from a lighthouse is visible for a distance of 12 miles. What is the area covered when the beam sweeps an arc of 150 degrees to the nearest tenth? Okay, so I'm going to say I'm looking like from the satellite view. So here's my lighthouse, and here's the beam here. So it reaches out for a radius of 12 miles. So that's as far as my lighthouse is visible. That's as far as the beam goes. So it says, what is the area covered when the beam sweeps an arc of 150 degrees? So this arc right here is over 150 degrees. So what I'm trying to find is, what is this area? What is this area covered by the lighthouse beam? Well, a sector area, this is just if I were to imagine this being drawn of a larger circle, this is just a sector of the area of a full circle. So I find that area by taking n divided by 360 multiplied by the area of the circle, pi r squared. Well, I find this fraction that the sector takes up of the whole circle by taking 150 degrees divided by 360 degrees, and then multiply that by the area, which is pi, 3.14, r squared, or 12 squared. Well, 150 divided by 360, that's 0.417, multiplied by 3.14, multiplied by 12 squared is 144. So in my handy-dandy calculator, 0.417 times 3.14 times 144 is 188.55 miles squared. So there are 188.5 square miles that this beam is able to reach on the ocean for all these lost ships coming in from sea. That's a pretty large area, even though the beam only goes out at a 12-mile radius. So that kind of gives you some perspective of as to what the area we're trying to find is. Okay, number 9 says you eat 5 pieces of pizza. This pizza has a radius of 8 inches. The pizza is divided into 8 even slices. What is the area of the pizza that you ate? Okay, so here's my pizza. Wow, that was pretty good. And it says it's split into 8 slices. So here's my 8 slices of pizza. Maybe this is a pepperoni pizza. Maybe this is a sausage pizza. I don't know. Make it whatever toppings you want. So it says you ate 5 of those pieces of pizza. So 1, 2, 3, 4, 5. So this is the section of the pizza that you ate. And the pizza had a radius of 8 inches. That's a pretty decently sized pizza, right? So the radius is 8 inches. So I want to find the area of the pizza that I ate. So I want to find this area right here. Well, what fraction of the whole pizza is that area? Well, there were 8 total pieces, and I ate 5 of them. So the fraction of the whole area is going to be 5 out of 8. That's what we're doing right here when I'm given an angle by taking the angle divided by 360, like on the lighthouse problem. I'm finding the fraction of the whole area, or the fraction of the whole circle that I'm taking up. Since I am taking up 5 out of the total 8 pieces, the fraction of the whole circle that I'm trying to find the area of is 5 out of 8. I multiply that fraction by pi r squared, or the area of the whole circle, which is 3.14 times 8 squared. Well, 5 divided by 8, that's 0.625 times 3.14 times 8 squared, which is 64. 0.625 times 3.14 times 64 is 125.6 inches squared. So if you eat 5 out of those 8 pieces of pizza, you've eaten 125 square inches of pizza. Holy smokes, that puts it into perspective, doesn't it? Okay, so that's the end of the guided notes section of this assignment, or of this lesson that I wanted to go over. We're about 20 minutes in. I'm going to spend the rest of this video going over some sample homework problems. So if you're feeling pretty good, you can move on, or you can watch these homework problems with me. This might be a good idea to get some of the homework automatically done with me. So homework problem number 8 says a dime has a circumference of 53.41 millimeters. What is the area of the dime? So let me draw my dime here real quick. Here's the dude. Oh gosh, I'm not even going to try to draw a face. So bad. That was pretty good. Okay, so the circumference, or the distance all the way around the outside of this circle, is 53.41 millimeters. And I want to find what the area of that dime is. Well, circumference is equal to 2 pi r. Area is equal to pi r squared. So in order to find the area, I'm going to need the radius. So I'm going to need to solve for the radius in this formula here. So the circumference is 53.41. And that's equal to 2 times 3.14 times the radius. So in order to solve for the radius, I need to divide by 2 and 3.14 on both sides. 2 and 3.14. Boop, boop. So the radius is equal to 53.41 divided by 2 and divided by 3.14. Or you can think of that as 53.41 divided by 6.28, because that's 2 times 3.14. 53.41 divided by 6.28 is 8.5. So the radius of this dime is 8.5 millimeters. Well, now I need to find the area. The area is equal to pi r squared. So the area of this dime is equal to 3.14 times the radius squared, or 8.5 squared. 8.5 squared is 72.25. So the area of my dime is 3.14 times 72.25, which is 226.87 millimeters squared. I measure my area in squares. So the area of my dime is 226.87 millimeters squared. So that's how I was able to find the area given a circumference. And I can do the same thing vice versa. If I had been given the area, I could have found the circumference. Okay, homework problem number 17 is another circle like this. So I have a circle, and the intercepted angle here between these two radiuses is 165 degrees, and the radius is 9 kilometers. And I'm trying to find the area of this space right in here. So the sector area, remember, is the area of the whole circle multiplied by the fraction of this circle that this sector takes up, which is going to be 165 degrees divided by 360 degrees. That will give me the fraction of this circle that the sector takes up. Well, 165 divided by 360 is 0.458 times pi times r squared, or 9 squared since that's the radius here, which is 0.458 times 3.14 times 9 squared is 81. So 0.458 times 3.14 times 81 is 116.49 kilometers squared. So the area that this sector takes up is almost half, 0.458 of the total area of the circle, and that sector area will be 116.49, or about 116.5 kilometers squared. So that's number 17 from your homework. And that's it. that's the end of this lesson. Hopefully now you're able to find the area of a circle, given the radius or the diameter. Hopefully you're able to find the circumference, given the area, or the area given the circumference. Hopefully you're able to find sector area given an angle measure and the radius, and be able to solve some real-world type problems involving sector area. So I hope that was helpful. Please reach out to me if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.